So as Julie mentioned, we will be talking about security, compliance, and governance in agentic AI. A bit about me. As Julie mentioned, I am the founder of Agento AI. Until very recently, actually, I'm still involved in Data Science Dojo. I have been doing Data Science Dojo teaching AI, machine learning, and everything related to that. For quite some time. And I'm also involved with, I'm a part-time faculty member at University of Pittsburgh. I'm teaching some Gen AI courses there as well. Okay, so what is an Achilles heel? Let's get started. So Achilles heel, actually, it is a metaphor for some kind of fatal weakness in an otherwise strong person, system, organization, and in our case, well, a system. So before we go ahead and look at it, why I think this is the Achilles heel of agentic AI, let's actually look at how agentic AI works. So, so there is very often, if you have, not all the time, but well, very often you will have a UX in front of all the things that you have built. You have some front end, maybe some personalization is going to be there. You have some infrastructure. You have, depending upon how you have deployed your, Amazon, AWS, Azure, Google Cloud, functions, containers, VMs, different names for different things. What kind of storage you're using, different kind of deployment approaches that you're taking. And here is that agency and what we really consider to be the agentic AI part, autonomy being one of the characteristics there. Then you have tools and actions, you have cognition, broadly speaking, understanding the intent, routing, planning, reasoning, reflection, all sorts of activities in that realm. We call them cognition. We'll bundle them under cognition. Then context management. Very recently, perhaps someone already has mentioned model context protocol, something new and emerging, and also something that is quite related to the topic that we are discussing right now. Then you have memory, short-term and long-term memory. Your vector store, think of that as a long-term memory. Your SharePoint, your Dropbox, long-term storage of things. Your personalization profile of the user, and the short-term memory, which is associated with the existing session. And in general, the dynamic context management that is there. Then you have prompting and prompt templates, model routing, not very recently, but recent enough. There is this concept of model routing that is emerging. So instead of every time me going and setting, which model to use for my specific agent or the entire workflow, there's this adaptive routing of my query, and then it is handed over to the appropriate model as opposed to or everything going to a single model. And there's some goodness to it, which is beyond the scope of the discussion here. Then you have your prompt guardrails surrounding it. And at the core of it, at the core of all of this is, well, your large language model, which is really knowledge compressed in a few 100 million to 1 billion to possibly 1 trillion parameters. And now with more modern models, you have built-in reasoning and some modern architectures, they have this built-in reasoning. And it is important to note actually here is some of the earlier applications, they were literally, maybe I will take a stretch and maybe exaggerate a bit. In many cases, some of the applications, the first application that many of us deploy when we get started with LLMs and building LLM applications, you start with building a very simple, basic Streamlit type application as your user experience, and you hook it up to an LLM. maybe with the very minimal prompting, but that is built into, somewhere in your UX code. Then later on, as we progressed, some of I would say some progression when we enterprises they started adopting, then there was this, you started to have this proper infrastructure, maybe some scalability constraints, and different kinds of data sources, proper deployment processes, and so on. But some of the more recent agentic AI applications, they have incorporated a lot of autonomy, a lot of tools and actions. Thanks to MCP, now you can connect to um, thousands of tools that could be for context retrieval, or they could be for taking some action. So and this is where we are, and this is what is making this entire business quite challenging. And this is what we will be talking about in this context. Many of us saw this news around Comet, Comet by Perplexity. So the Comet web browser, they launched it. And then security researchers, they were able to trick the browser into performing unauthorized actions. And what was the reason they were able to influence the browser to take indirect prompt injection, access to multiple tabs, emails, credentials, file system, banking session, and so on. As expected, Perplexity patched the vulnerabilities and limited agent scopes. We have deployed Agento at big companies, and when I talk about big companies, I'm talking about really big, potentially, revenues in tens of billions of dollars. And one interesting thing that has happened is our interaction, our discussions with InfoSec, the security folks, and the legal folks, they have become quite interesting. You would say, hey, I mean, wasn't security an issue in all of the SaaS problems or SaaS software deployments? Wasn't this a problem, even before agentic AI? Yes, there were problems, but these problems actually get quite challenging because of two reasons. Agents have autonomy. In the previous generation of automations, your Zapier automation, your UiPath or Logic apps, or some of those approaches to automating things, you had some deterministic rules, and then you had set things up, and you knew, for the most part, you knew the action that would be taken and what is the condition that will trigger that action, and whether that action will be taken or not. But in agentic AI, the challenge is LLMs are they are handling responses, they are handling the reasoning step, the planning step, and also interpretation of the rules. It is deferred to an LLM, and LLMs are stochastic by nature. Confusion can happen, right? So it's almost the more time I spend with large language models, the more I realize, how tricky it is when you even human communication. It reminds you of the complexities of human communication, right? If I have to get some work done, if I delegate some work to someone, I can give them a flowchart. Hey, when this happens, do this, else do this. And then I can give them some of the possibilities. And as long as the possibilities remain only those, well, things are going to be okay. But what if I gave them maybe some kind of instruction manual without running them through, without walking them through all the scenarios? And that's an analogy where this having a deterministic set of rules versus stochastic nature of LLMs. That's pretty much the analogy. So LLMs decide what they need to do. They reason the plan, interpret the rules, and decide what needs to be done. And then agents tend to be agentic AI is one of the core characteristics of agentic AI is that they are going to be autonomous. So you have given control to an LLM to make a decision, um, maybe read a file, delete a file, access this data set, interpret this data set, and so on. Um, Now, this autonomy can be abused. And very often, when you build agentic AI systems, the agentic AI systems usually they rely on a service account. There is a single account, some kind of master, super user type account that has access to everything. Or potentially, if I am the one, right? So it's a shared agentic AI system. If I'm the one who enabled that connection, then anything that I have access to, by definition, the agent um, has access to all of that. What if that agent gets used by someone else? If they indirectly interact with that agent, so these kind of challenges they make agentic AI dealing with the security and compliance and governance challenges in agentic AI very difficult to handle. So, what are some of the security challenges? I think I mentioned at least the first one already. Agentic AI systems, they often rely on service accounts with elevated permissions, resulting in unintended behavior, right? So, um, if I go to today, if I go to log into Gmail, well, I will have access to my mailbox. If I go and access SharePoint or Dropbox or Box or any of the data repositories, I will have access to, well, whatever access I have been granted. But when we go and access these tools and these sources through a service account, there can be unintended consequences. Um, Within agentic AI workflows, the whole context retrieval and interpretation and retrieval, for the lack of a better word, right? So you go fetch context from here, fetch context from there, do some reasoning, reflection, thinking. You go and again fetch context. All of this, one bad actor can actually inject some context and and then just make stuff happen. Um, there is somewhat connected. The second and third point could be somewhat connected. You have data leakage through tools and memory. You're storing memory. You have the either short-term or long-term memory from your sessions. Perhaps uh, user feedback from one user, it is bleeding into or it is leaking into another user's session or another user's context. How do you actually separate these? So these kind of tools and when you use them, perhaps you're logging the interaction as well. So what should you log and what you shouldn't log? That's actually a very interesting question. Your conversation histories, they may expose PII, any kind of proprietary information, confidential information. A lot of that is possible. So there are a lot of issues there. And for that reason, there are different mitigation strategies that are possible. You can be sanitizing the input um, and just make sure that you sanitize the input, remove anything that shouldn't be there. Then isolation and create isolated sandboxes. Uh, let's maybe I can give an example, right? So LLMs are well, they are next token predictors under the hood. Like at the very core, LLMs are essentially next token predictors. When you ask an LLM to do a math problem or some kind of complex reasoning task, um, potentially there has to be the steps have to be broken. The task has to be broken down into steps. Similarly, if you're asking an LLM to do a math problem, one of the approaches is you use some kind of pattern where the problem that you're given to the LLM, you convert that problem into a programming problem, and now you execute that piece of code to solve that math problem. And now, what if your agent has elevated permissions, and then some bad actor figures out that that is the case, and then instead of giving it a math problem, it actually gives it some problem that becomes your problem for longer term, right? So it ends up deleting some rows in the database. It ends up sniffing something in from within the whole enterprise data repository. So it's usually a good idea when you think that you have some kind of execution that is happening on behalf of the agent. Usually, it's a good idea, and there are frameworks. There are in open source. Open source is amazing, so you can actually go and um, execute these pieces of code separately outside of your agent. Even you isolate even from the agent, right? So it does and takes action, and it is isolated in a manner that the only job it has to is to execute the code. It cannot just go around and sniff on things. There are other techniques. You make sure that you're aware of the source of data provenance check. Where is the data coming from? Managing the identity of the agent, redaction of memories, and also persist them within certain scope. Only the memory persists only within the scope of where the reasoning was happening. It is not actually shared across widely. Then inter-agent communication contracts. I mean, what an agent, when context is given, what they can do, what cannot do. And then role and relationship-based access controls. Basically, um, it's even better that you delegate, or the users who are using the agent, those permissions propagate, and the agents assume that they have the permission of what the user, or whoever called them, or whichever user called them. That same permission is actually, it trickles down to the agent. Then there are compliance challenges. You have, there's a small typo here, but yeah. So you have agents may autonomously pull and process data across jurisdictions, right? So you have cross geography deployment. Things, some data has to stay in Europe. It did not end up staying in Europe, and then you suddenly, without even knowing, not because of your own doing, you are actually not in compliance with GDPR, or you're breaching some other some compliance, or some kind of some regulation. Then also, um, there is a lot of thinking and reasoning and planning and reflection that happens at every step, right? So if there's ambiguity, you make an LLM call with all the context. When the response comes back, hey, I need to critique this. Now, the critique is generated by yet another LLM call. Once the critique is ready, you go back and send it to, hey, can you correct the answer? Yet another LLM call. Then now, which tool should be called? Should I call my Python tool, or should I call this MCP server to connect to my CRM? All of this happens with once again with the help of LLMs. And there is a lot happening that is auditability and traceability of all of this. It is going to be actually very, very hard. Also, in data governance, we know data lineage and model lineage in general is important. But when a response comes in, can we attribute it to a specific model or a specific data source, or really for anything? Do we know? Can we trace it back? How did we get this answer? Because there may be compliance reasons for that. So for that, if you have any reason to believe that this matters, this is important, then you will have explainability logs. You can have some kind of compliance validation on the fly. We can, you can at the input level, at the output level, at the intermediate step level. There is so many different places where it is possible that you may be out of compliance. And well, you have to have some kind of validation at each step. That's possible. And the next one is obvious. We have talked about it already, like maintain some kind of lineage of when the inference, this step-by-step reasoning and inference happened. How do you actually maintain lineage? Then you have um, your data classification has to be embedded in the reasoning process. Um, I think a very simple and easy to understand example in this case is, let's say my I have access to some sensitive data. So I have implemented role-based access control. I can go and access many data sources. Some data sets are classified as sensitive, confidential, public, or private, or different kind of data classification. So once I ask a question, or I use the agent, what should be the data classification? Let's say this is an interactive assistant. This is my assistant, AI assistant, that helps me answer questions about what's there in my enterprise repository. So what should be the classification of my response or the decision? Um, and what should be the process to control um, what decision I take, where if there is whether I surface the response, what should be classification of the response, and when there was a sensitive or private or confidential data that was involved, what should be the decision-making process? How should I actually classify my action as a result of me touching, or my agent touching some sensitive data? Then there are governance challenges as well. You have different agents, different tools and connectors and data sources that have different access levels and policies. Maybe your enterprise has a data source that everyone has access to. Maybe your enterprise has some data sources that are very sensitive in nature. Some action, some data warehouse, some tools, a CRM system, some customer information. Um, they have different levels and varying levels of policies and constraints. So how do you enforce a consistent policy across all layers? And it is non-trivial, right? So this is the reason I call it the Achilles heel, is that we are living this right now, right? So we have customers, we are paying enterprise customers, and they love the tool. But the more agents that we build, the more scenarios that we bump into, the more we realize that the building the agentic AI part is the easier part, and then managing the security and compliance and governance and keeping all of them in compliance, that's actually a very difficult piece. uh, then alignment can also drift from original policy goals, right? So you start an agent, it and it starts reasoning, starts gathering context, and along the way, as it gathers more and more context, at the end of the day, these autonomous agents remember that each step is a stochastic step, and it drifts away. It does not understand. It it drifts away from the original alignment that it was given. And then, of course, the model and data lineage problem is, of course, there. And then the human in the loop problem, right? So if you make if you make an agent autonomous, going back to the Comet web browser example, when you make your agentic AI workflow, or in this case, let's say web browser, um, to what extent do you want it to be autonomous? And how often the action should be completely autonomous, and how often can it be a human should be looped in? So these are the challenges. Perhaps have some human in the loop threshold, right? So if this happens, I will not call this, I will not loop in, I will not defer the decision, or the agent will not defer the decision to a human unless some conditions are met. Then having centralized policy repositories for agents is going to be there. Have some compliance APIs, right? So we have very detailed APIs for agent creation, reasoning, accessing data, augmenting data, guardrails, evaluation, everything. But we are we are going toward building compliance APIs. Now, how do you build those compliance APIs? How do you enforce those policies? Um, can there be any, if you're using any external agents, so you're using some agents from this platform, another agent from a different platform, can there be third-party vetting? I think notably Docker in this space, they have created this marketplace for MCP servers, and they are actually vetting out the entire supply chain of those MCP servers. Then monitor reasoning logs and realign periodically if you see that, from the logs that things did not go as you were expecting. Then realign and fix things. Agent certification process, right? So perhaps for more sensitive, depending upon your use case, right? So if you're deploying in an enterprise, whether it is internal or external, what kind of decision, what kind of automation, and so on, what kind of compliance implications are there? Depending upon that, you will actually maybe there should be an agent certification process, right? And then once again, the sandboxing part is there. In this case, maybe sandbox any external agent to bring in before you actually deploy it, sandbox it, use it, do not give it a lot of control, and then slowly, gradually release it. I was actually having a discussion with one of my former co-workers from back at Microsoft days. Now she's working at a different company, a leading company in tech space, and they released their MCP server, and they did not enable any write permissions. They only enabled read permissions initially. And those are the kind of incremental, slow, gradual steps that all agentic AI builders have to take in order for the entire system to remain very, very manageable and stable. And that's pretty much it. I think I took exactly 30 minutes. So happy to take any questions since Hamzam and Julie mentioned that I can take questions.
Raja, first off, thank you so much for this. This is the real deal, and we need to be talking about all these things as we go. What I want to do is, Julie, we have at least 3 or 4 questions if you want to take them on. And if you
Yeah.
have any questions,
So let's get started with our
sorry, go ahead.
Yeah, please
so
go
let's
ahead,
get started
Julie.
with our first question.
Okay, I
All
will go
right. So our
ahead.
first question I'm seeing on the lineup. Oh, yeah, you
Go
okay.
ahead, please.
Sorry,
Julie,
you go
please go
ahead.
ahead. Yeah. Okay,
All
I will
right.
read it
How much
aloud.
overhead is
Mhm. Okay, please go ahead, Julie. You can go ahead. Yeah.
I feel we keep yeah, all right. So how much overhead is added to the system by adding traceability, data lineage, and data provenance? What are best practices when incorporating these practices to a system architecture?
Okay, yeah, thank you, Julie, for this, and actually Sakina for the question. So a lot actually. So the more it depends upon what you're trying to do here. And this is where your product thinking will actually kick in, right? So if it is not needed, um, don't do it. And once again, the caveat is don't go back and tell people that Raja said don't do it, right? What I'm saying is know your customer, know your scenario, and build only what is needed. Because when you add more overhead, there are ways to actually make these traceability and all these things asynchronous. When you're logging them, they can be done asynchronously. Data lineage and provenance, well, easier said than done. I mean, having spent so much time in with data, one of the interesting things is that everyone likes to have high quality data, but no one wants to work toward having an high quality data. No one wants to. I mean, so because it is painful, right? Who wants to go and just fix things all the time, right? And usually it is some kind of incidents or some kind of metrics that are off, or some kind of incident that exposes data quality problems. So yes, there's going to be overhead, both in terms of your agent performance if not done right, and also in terms of your organizational you know uh, orchestrating all of this as an organization. The engineering part of it and the cultural part of it, it is going to be actually difficult. Um, but I mean, it is what it is. If you need it, if this needs to be done, it needs to be done, right? So, and you will have to be compliant. Um, Julie, you want to go ahead? Next question.
Yeah. Our next question is, how do you see clearing of the agent memory over time as a solution in business processes? I find that I want the agent to perform a task and then forget when there's a new task. Also, for code sessions, I've noticed that if I work with the agent for too long, it builds a kind of momentum and keeps introducing the same bugs even when I explain not to. So a restart is needed there.
Yeah, thank you, Julie. So welcome to Agentic AI, right? So this is how it works. Because I mean, if you clear the memory, so let's say if I built a system, right? And we have seen this, and from time to time, I mean, these kind of issues happen, right? So now you're building up the memory. There are ways you can reason, hey, is this question related to the previous question or not? I mean, I'm simplifying it, oversimplifying it. So you can say, is it related or not? If it is related, I will answer in the context of that whatever happened. And if it's a brand new question, you can reason, understand the intent, and figure out, and then answer the question. But from time to time, it will happen is that any follow-up question that you ask is your intent understanding, it misfires, and it actually will interpret it in the previous context. Well, if I mean, once again, when you start building these systems, sometimes you feel helpless, right? So what do you do? Because and having built traditional machine learning models and also now agentic systems for a long time, I think optimize for averages. Sometimes we may be obsessed with, hey, this response is not coming right. resist that temptation, right? So resist that temptation, optimize for averages. Your 10,000 out of the 10,000, if you mess up on 5 or 10 of them, that's okay, depending upon the cost, the implications of it, of course. But do not fret about, hey, this particular query, it does not get right. Try to fix it, but trying to fix it, remember, it is a stochastic. Trying to fix it, you don't know how many others are going to be messed up. And for that, evals are important. I mean, maybe you have some set of baseline queries. I don't know if this was a fairly long, convoluted answer to a question. Hamza, please help me answer the question. Is
Raja,
anything that you can add?
I think one of the things that we've done, and you know this, that the answer is build vertical AI agents.
Oh,
Fixate,
that's okay. Yeah, absolutely.
fixate
Yeah.
yourself onto agents that do one thing and do one thing really well.
Mhm.
That sort of helps you decide, you want long-term memory, you want short-term memory, you need the overhead, you don't need the overhead. Like some agents which are customer facing needs to be built different, some agents which are internal needs to be built differently. So I think as machine learning was, right, there's not no two machine learning ecosystems are the same. No two data scientists will even agree on a model, right? So I think
Yeah, yeah.
that's the crux of it.
I mean, as they say, all models are wrong, some are useful, right? So yeah,
Yes.
so that's going to be the case. And then yeah, I mean, thanks Hamza for chipping in. I think one of the things is that build very, very specific agents to a task, narrow down the task, and see because if you want to create how general do you want it to be, right? So if you try to create a generalist, there's a chance that the generalist will actually fail at some point in time. So build specialist agents, and I think that's probably the way to go.
Yep. Well, I think this has been great.